Hey everyone, today we're going to discuss about exponential models. So exponential functions can be used to model exponential growth. So we can use exponential functions to model things that grow exponentially like population, interest, loans, etc. and etc. So the rule for exponential growth can be modeled by y equals ab raised to x, where A is the starting number, B is the growth factor, and X is the number of intervals. In discussing exponential models, we may encounter a particular variable. This variable is E. E is equal to 2.71828, so on and so forth. It's a number that never ends, and we may encounter this whenever we discuss about exponential models. So let's have an example. Let's have this word problem. Jean deposits 30,000 pesos in her account. She gets a 5% annual interest. If she makes no deposits and no withdrawals, what will be her balance after 3 years? So let's analyze what will happen to her money after 3 years. So initially, she has 30,000 pesos. So that's the starting money. Now, after 1 year, we will get 5% of 30,000 and add it to her current 30,000. So her money will increase by how much? 30,000 plus the 5% of 30,000 times 0.05. That's the decimal equivalent of 5%. Now, since we're dealing with this is 100% of the 30,000 and this is the 5% of 30,000, we can simplify it with a single term. We can have it as 30,000 times 1.05. How did this happen? Remember that this 30,000 here is the entire money. That's the 100% of her money. And 30,000 times 0.05, that is the 5% of her money. So combine it together, we will get the 105% of her money. That's why we can combine this as 30,000 times 1.05. So 1.05 of her money. This 1.05 here is what we call the growth factor. So whenever 1 year passes, her money grows by 105%. It increases because we always add 5% annually. That's her annual interest. So at her second year, we get the money again. That her money is 30,000 times 1.05. And we multiply this number here with another 1.05. Since another year has passed, she will get another 5% interest. So her money will grow by 105%. So that's how the growth factor works. It tells you how much your money grows. So 30,000 times 1.05 times 1.05. So that will be 30,000 times 1.05 times 1.05. So we can condense it as 1.05 squared. Now for the third year, we can have 30,000 times 1.05 squared. This is her money right now, isn't it? We're gonna multiply her current money on the second year with another growth factor. Since another year has passed, she gets another 5% interest. So this will become 30,000 times 1.05 squared times 1.05. So this becomes 30,000 times 1.05 cubed. Take note that this is similar to our function that we mentioned earlier. Y is equal to a b raised to x. A is your starting number, 30,000. B is the growth factor, the 1.05. And x represents the number of years, which is 3. Actually, we can make a shortcut and just apply the function immediately. Replace A as 30,000, B as 1.05, and x as 3. We can do it immediately like that. But I just explained you how does the process works. But in our next examples, we can just make use of the function here, y equals ab raised to x. So let's solve 30,000 times 1.05 cube. Her money is now 34,728.75. So that will be her money after 3 years. So the interest contributed with the growth of her money. So that's how we model exponential functions in real life situations. There are a lot more examples which I encourage you to search more and learn more about this. So I hope you guys learned a lot today. Thank you guys for watching and see you guys on the next video.